Good evening, everyone. Um, for the last 2 decades, we focused on reducing energy use. And today, the conversation has shifted from energy efficiency to carbon intelligence. I'll share practical pathways on how we move from low energy design to genuinely low carbon architecture. Increasingly, sustainability is no longer an add on, it's becoming a core design expectation from clients, regulators, and markets. But the real question is, are we solving the right problem? Right? This is where I believe that the shift is happening. For 20 years, we've optimized operational energy, HVAC, efficiency, lighting, and renewables. But operational carbon is gradually decreasing with grid decarbonization. Embodied carbon is rising, and almost 50% of a building's lifetime carbon is locked in before the building is even occupied, which means carbon is largely a design stage decision. Energy efficiency is about reducing the loads and improving systems. Carbon intelligence goes further. It asks the questions like, what materials are we using? Can we electrify fully? Are we designing for lifespan and resilience? And are we integrating renewables meaningfully? It's a broader systems question, right? Now, this is where it becomes actionable. 5 pathways we consistently see that are working. Number 1, passive first, orientation, shading, daylight ventilation. Number 2, electrify everything, reduce the fossil fuel dependency, whether it's LPG, whether it's coal-based, any other fossil fuel consumption. Measure embodied carbon. If you don't measure, you can't manage it. Number 4, integrate on-site renewables, right? Whether it's PV, storage, integration, all of these aspects need to happen on-site. And number 5, monitor and adapt. Post-occupancy data closes this loop, right? So with post-occupancy data, we are now able to kind of manage, monitor, and continuously make sure that the building is meeting what we planned for, right? So low carbon is not one big gesture. It's multiple intelligent decisions throughout the entire process. Carbonless architecture is not a technology problem. It's a design integration problem. Simulation tools are not the goal. They're decision support systems. They're design, and this is where we need to kind of use this to leverage rather than to use this as a way to show that we've done something, right? When data enters the early stage design, whether it's the EDP, the design development, working drawings, the design becomes climate responsive by default. So the question now is, where is the carbon decided, right? So when you look at this process diagram, you see that carbon decisions are not made during commissioning. They're made here, whether it's in the volumetric stage, whether it's in the space planning, the structural grid, or the different facade ratios that we arrive at, right? So by the time we reach construction, the flexibility is already very minimal. And so low carbon thinking must begin at the concept, right? At the concept level, if you're thinking about how do we bring down the carbon of this project, then we're already setting ourselves up for a much better product at the end, okay? Now moving to the software complexity, right? We use advanced tools, but tools are secondary, right? The value isn't intrinsically in the software as such, but the value is in interpreting the data and feeding it back into our design choices, right? And this is where there's very often a gap between the numbers that you create and the design decisions that are being made by someone else. So when these two are merged, when these two are happening in tandem, that's when you're able to extract the maximum advantage and actually unlock all of the hidden potential in the projects as well. All right. So these outputs like radiation maps, daylight studies, CFDs, these are not reports, they're design intelligence, right? And that's how they need to be seen. They inform the facade articulation, material choices in the building, the window ratios, the public space comfort, right? This is where our outputs actually make some kind of meaningful change. Right. So whether it's daylight, radiation, CFD, all of these are things that are going to impact your building, right? Um, Passive design reduces the operational carbon before we even think about technology, right? Now, these are some of the, once passive is optimized, then technology layers in. So smart systems, storage, DITV, monitoring, right? So technology should amplify good design, not compensate for poor orientation, right? Um, Rating systems are also important frameworks, and we use them as frameworks, not guarantee low carbon. We must go beyond checklists and measure this in actual performance, right? So while this is important to enable us, this is not the end goal either. All right, so these are a few projects I'm quickly going to go over. I won't go into detail. But essentially, this was one master plan project. We worked at a very large scale. And then from there, we got into each of the housing blocks and looked at individual elements of repeating blocks, worked with massing studies, worked with radiation, worked with wind flows during different parts of the year, and then informed the design of the individual towers as a cluster, as open space, as shading, how these could all work together to kind of improve and optimize and of course reduce the dependence on mechanical systems as much as possible. Right. This was another high-rise tower, different typology, where we were looking at all the different aspects of the building. And while they were also looking for compliance, they were also looking to actually bring down consumption. So this was another interesting project based in Bombay, different climate. All right. This is in a cold climate. In cold climates, we were looking at harvesting the heat, bringing in as much of the good heat as possible to reduce heating loads, and also looking at where we can bring in some amount of light. So in the north, we were able to bring in light. Normally, light and heat is not looked at as something you bring from the north. But in this case, at a specific time of the year, in the winter months, we were able to bring heat from the north and we angled the balconies and closed them and brought in a new kind of design onto that facade to bring in the heat and capture it on the opposite side, the cold side of the building. Okay, so moving on. Now, this is important, right? Um, at the end of the day, developers are thinking about future tariffs, carbon taxation, ESG pressure, and asset valuation, and climate risk, right? So low carbon is not a cost premium, and we need to position low carbon as something which is, in fact, a risk mitigation. And that's something that also makes someone feel safe, makes someone feel willing to invest in something for the future, right? Okay, so build form, energy, these strategies that we talked about earlier, these strategies scale. So from material selection and embodied carbon assessment to PV optimization, water systems, urban heat island mitigation, low carbon thinking applies at building level, campus level, and at city scale, right? So there is so many things to be done, so much to be incorporated as we get more and more into it. And these are kind of some of the things that one gets into as you go deeper, right? So all of these things are going to scale and get more and more intrinsic to the kind of projects that you do, the kind of buildings that we create in the future. All right. So with that, the future of architecture is not low energy buildings. It is climate intelligent buildings, and climate intelligence begins at the design table. Thank you very much, everyone. That was my